The matrix diagram is a data representation technique that helps project managers in visualizing and analyzing complex data sets in a structured manner. It organizes data elements into a matrix or table format. It enables project managers to represent the relationships between various objects in an organized and understandable way. Different aspects of the project, including stakeholder interactions, resource distribution, risk management, and process flow, are illustrated using matrix diagrams. Matrix diagrams consist of rows and columns, and each row and column represent a specific object or data element. The intersections of rows and columns contain information that represents the relationship or interaction between the respective items. The data elements in the matrix can be qualitative or quantitative that allows project managers to analyze the strength, frequency, or impact of the relationships. The project manager can use a variety of matrix diagram shapes such as L, T, X, and Y, depending on how many variables may be compared. In the upcoming slide, we will discuss each of them in detail. The L-shaped chart is the simplest and most common matrix diagram. It compares two sets of data in a two-dimensional table. One data set is represented on the left-hand column, and it is compared against the second data set in the top row of the table. Numbers or symbols notate the relationship between pairs in the intersecting cells. You can also tally the scores and note the totals on the end rows to help rank or prioritize items within the chart. You use the L-shaped diagram when you need to compare two groups of items or one group to itself. The example in front of you on the screen shows different features and their corresponding costs and requirements. A rectangular matrix that is formed like a T, when one row or column is longer than the others, is known as a T-shaped matrix diagram. When one element interacts or has more relationships than the others, this form might be helpful. The T-shaped matrix, for instance, can be utilized in a responsibility assignment matrix, or simply referred to as RAM, to represent the obligations of a particular resource or department across several project activities or tasks. A T-shaped diagram is essentially two L-shaped matrices joined by a single list. This matrix lets you compare one list, the center pole of the T, to two other groups. It is helpful when you have two distinct sets of questions about a core group. You use the T-shaped matrix when you need to compare two groups that are related to one primary list. For instance, in the example in front of you on the screen, work shifts are related to required tasks and the employees that work at that location. A specialized type of matrix diagram that emphasizes cause and effect interactions between various components or elements is the X-shaped matrix, also known as the cross matrix or causality matrix. It is especially helpful for identifying the root causes of problems, analyzing the effects of certain variables, or figuring out the interdependencies between numerous project-related aspects. The diagonal lines that cross one other to form a X pattern within the matrix define the X-shaped matrix. The X-shaped matrix is useful for comparing two pairs of complementary lists. It is similar to the T-shaped diagram, but it extends the T-shaped chart to include an additional set of data. The result is a diagram with an X and Y axis forming a cross or X shape that compares four total groups of data. In this relationship matrix, each axis is related to the groups immediately adjacent to it, but not the group across from it. For instance, in the example in front of you on the screen, office locations are related to the product managers and principal engineers, but not to the new features. You use the X-shaped diagram when you need to compare four groups of items. A specialized type of matrix diagram used in project quality management is the Y-shaped matrix diagram, sometimes called the Y matrix. It is especially helpful for evaluating and ranking probable causes or contributing variables to a given issue or impact. Project teams can prioritize their efforts by determining the most important or influential reasons with the use of the I matrix. The effect, potential causes, and evaluation make up the three primary components of the I-shaped matrix diagram. The Y-shaped diagram relates three groups of items that are all related to each other in a circular flow, that is from a to B, B to A, B to C, C to B, and C to A, or a to C. These relationships are depicted in a circular diagram. Use the Y-shaped matrix when you need to compare three tightly related groups. It can also be used as a practical simplification of the C-shaped matrix. The example below shows the relationships between employee shifts, tasks, and warehouse locations. Last but not the least, we have the C-shaped matrix. A correlation matrix is generally referred to as a C matrix. The pairwise correlations between variables in a data set are shown by pairwise correlation matrices, which are square matrices. It is a useful tool for comprehending how variables relate to one another and how they depend on one another. It is often used in several disciplines, including statistics, data analysis, and machine learning. A C-shaped diagram, like a Y-shaped matrix, compares three sets of data. However, the C-shaped matrix relates the three groups simultaneously in a three-dimensional cube diagram. You use the C-shaped matrix when you need to compare three groups simultaneously, for example the people, products, and processes in a factory. There are several more types of matrix that are used according to the requirements. The collaboration and communication amongst project stakeholders are improved through matrix diagrams. They give team members, departments, or third parties a consistent visual representation that promotes comprehension, alignment, and productive communication. There are different significances of matrix diagram in data representation. Matrix diagrams provide a visual representation of the relationships between different elements. They assist project teams in comprehending the relationships between and effects of various components, finding dependencies, comprehending cause and effect relationships, and making wise decisions are all based on this analysis, which is essential for raising the quality of projects. Project teams can identify patterns or trends in the data by using matrix diagrams. Teams may identify similarities, variances, or outliers by graphically organizing and comparing data items based on various criteria. This pattern recognition promotes focused activities for improvement, as well as helps in understanding the components that lead to high-quality performance. In project quality management, matrix diagrams assist data-driven decision-making. Project teams may analyze choices, assess risks, and prioritize activities based on an objective analysis with the use of the visual representation of relationships and criteria. Teams may make decisions that are in line with project quality objectives by using matrix diagrams, which offer an organized method for taking several elements into account simultaneously. In project quality management, matrix diagrams can be used to analyze and control risks. Teams can find possible risk areas and assess their effect on quality results by outlining relationships between various aspects and criteria. This study supports proactive risk mitigation techniques, ensuring that project teams are ready to handle any hazards that might have an influence on project quality. Matrix diagrams helps the project manager in resource allocation decisions related to project quality management. Teams can identify resource-intensive tasks or crucial aspects that need extra attention by examining the relationships between the elements and criteria. This study aids in resource allocation optimization, ensuring that sufficient resources are allocated to activities with a significant impact on project quality. Matrix diagrams support process improvement effort by revealing areas of strength and weakness. Teams can identify areas that need improvement or intervention to increase project quality by establishing relationships between elements and criteria. This analysis enables project teams to concentrate their efforts on the particular procedures, activities, or elements that will have the most influence on the quality of the final products. The visual representation and analytical capabilities of matrix diagrams can help project teams in better understanding the project quality aspects and take focused actions to attain the desired quality results.